Hey, good day, everyone. So we're gonna get started, right? So a quick announcement about the final exam and final exam reviews. I actually sent you guys an email about the final exam and the final exam review. Basically, it's not a cumulative final, so it's just like everything after test number two, just mainly based on chapter four, right? So we're gonna review on May 7th, Friday, May 7th, which is next Friday. And then on Wednesday, right, May 12th, you're going to take the test number three or final exam, if you want to call that. And then that will be the last day of our semester. So May 12th is the last day of the semester. You can mark those 2 days. And let's just continue where we left off. But before that, do you have any questions, about the final and any assignments and anything? Okay. All right, so let's open the PowerPoint from our where we're going to talk about expected value today, and also some other topics. Okay, so let's move on to 4.2, right, on the expected values. And we finished section 4.1 last time. So expected value is an important measurement, right? Or you can call that index. A lot of investors, or like if you are investing any like asset or in the stock market or any investment activities, you have to deal with the expected values. And also, if you go to casino, play any games, actually, you can also use the expected value to calculate the chance of doing winning money from the casino, right? So those are all important things about expected values. Now, so first of all, let's look at the definition of the expected value of the random variable. So we're dealing with the random variable here. Okay. Okay, 1 second. Let me get a pen working before we start it. Current slide. Let's see. For some reason, pen is not working. Okay. It's okay. It's okay. Maybe quickly close out this. Okay, and reopen it. Expected value. Okay. All right, so let's talk about expected value. So most of the time when we talk about expected value, it's associated with a random variable here, right? So we're going to look at a random variable x, which is a numerical measurement of the outcome of the experiment. So meaning, for example, if you go to casino and you play the slot machine, right? Or like play the blackjack or any like games, usually you have several outcomes, right? Either win some money or lose some money, right? So those are it's like when you play the games like an experiment, and you're gonna have different outcomes, either winning the money or losing the money. Same thing for investment activities. If you invest the money in a certain stock or bonds, you either win some money or lose some money, right? So those are the outcomes we're talking about, right? And also, so in general, probability, we're concerned about probability of those outcomes, right? So probability that X takes on the value X. So if you win some money, you want to see the monetary reward. So usually it's associated with monetary reward. if you lose money, it's going to be you're going to have a monetary loss, right? So we will look at that, and also the associated probability with each outcome. All right. So now about the total probability. So we know that for any probability distribution, the total probability is always 1. So you will always look at it as 1. And also, okay, hold on. Okay, so I think that's good now. Should be good now. So, so we're talking about probability distribution. So any probability distribution, it's like when we're talking about total probabilities, it's always 1, right? So one of the key characteristics is total probability. So suppose that X could assume any values, right? Let's say we have X1, X2, Xn, and each outcome is associated with the different X values, meaning each outcome would associate with different monetary reward or monetary loss, right? So typically that's the case, monetary reward or monetary loss. And it would take different values, but we know that the total probability here must be 1, okay? And let's see, so expected value in essence is like average outcome, right? Average outcome in terms of the dollar amount. So it's also we call mean, right? Expected value is like another way of saying mean. It gives a value that we can expect to observe the average value of different outcomes. And usually it's appear in a monetary dollar sign, right? So you want to know eventually you are winning some money or losing some money. Okay, and this is the formal expression for the expected value, mu of X. This means mean average of all the outcomes, mean outcome or average outcome equal to expected value, and then we do summation sign I from 1 to n. So you look at different outcomes. Each outcome has a monetary reward or loss associated with it, and then multiply by the corresponding probability. Okay, you can also just write it as simple form, which is summation of X times P of X, right? X represent different monetary reward or loss, and then P of X represent the probability associated with it. All right, and any questions so far about the expected value? Okay, put in a simple language would be average outcome, right? Okay. Now, here we may have several outcomes. That's why here you have this notation I from 1 to n. So you may have 5 outcomes, then x1, x2, x3. If there are 5 outcomes, that means we have 5 random variables, x1, x2, x3, x4, and x5. And each one has a probability. So x1 represent associated with p1, right? Probability of first one, p1. And then this one associated with p2. And that's p3, p4, and p5. And we know that when you sum up all the probabilities, so p1 plus p2 plus p3 plus p4 plus p5 should be equal to 1. That's like a constraint, right, on the total probability. So expected value describe the expected monetary return of the experiment. Right? Typically, we talking about investment. So return on investment, right? It's very familiar term. Return on the investment. And we're going to look into that, see how we'll calculate the return on investment using the expected value formula. So let's look at this. Let's say we have an investment in project A. So typically you have different projects result in a loss of $26,000 with probability of 0.3. So this is first outcome, right? First outcome. And then you're gonna break even. Second outcome is break even. So first outcome is loss. Negative 26,000. And the second outcome, this is second outcome. We have break even, meaning no gain, no loss. So zero, right? $0 with probability of 0.5. Okay. And then the third outcome is the profit. So this is the third outcome with a profit of $68,000 with a probability of 0.2. If you look at the total probability of 0.3 plus 0.5, adding 0.2, it's gonna be 1, right? If you sum up that, will be 1. And second investment is in project B. Okay. Similarly, for project B, that's a loss with $71,000 with probability of 0.2, break even with the probability of 0.65, profit 143,000 with probability of 0.15. And you want to compare which investment is better. So you have two investment opportunities, and you want to pick a better investment opportunity based on the return on investment, right? So now we can look at it using the expected value formula. So return on investment. So basically you just calculate return on investment in project A. So typically the table will help. Okay, so you look at all outcomes. Okay, so you have a loss case, right? You have a break even. Also, you have a, I think a gain, right? A gain case, a profit. I think they use profit. So let me use a profit as well. Loss, profit, break even, right? Very standard concept in business field. And that's outcome. And associating monetary reward or loss, we can look at that as well. And after that, we look at the probability of X. Okay. And all right. So now for the loss case, right? If you look at it, loss is 26,000. Since it's a loss, so it should be negative 26,000. That's first outcome. And break even, we know it will be 0, right? No gain, no loss. Break even. The third case is profit of 68,000, but it's 68,000 positive, right? And each one of them has a different probability. So the loss case probability is 0.3, break even is 0.5, and then the profit case is 0.2. So now the expected value formula of average return equal to expected value. So it's just going to be X times P of X. Okay. That means we need this one more column, which is X times P of X. This is where the average return comes in. So you multiply negative 26,000 by 0.3. That will give us the expected return for the first outcome, which is negative 78,000. Okay. So under the loss case, on average, you are losing 78,000. Okay. And break-even case will be 0, right? No gain, no loss. For the profit case, it will be 68,000 times 0.2. And that's 13,600. So all you have to do is just sum up that, meaning you add up all those to average return, right? So negative 78,000 plus 0 plus 13,600, and let's see what is actual return on investment. So the negative 78,000, adding 13,600. And this turned out to be negative 64,400. That means that the interpretation of this outcome is on average, the project A will render an average return of negative 64,400. Okay. And what do you think? Is it a good investment? Any idea? What do you think?
Wouldn't it be no since it's in a negative?
Yeah, it's not a good investment. Meaning, anytime if you invest in this project, you're losing money, right? That's not a good idea. Okay. Anytime if anything makes you lose money, that's not a good investment, right? So ideally, we expect to have a positive return, right? At least you gain some money, and you have a motivation to invest in the project. Now let's compare the second project, project B. And we're also going to find out return on investment. So anytime in your future or in the near future, if you have to make a choice on investment, you always come up with this table, right? That will help you a lot. So you look at all the outcomes in terms of again, we have three outcomes: loss, break even, or profit. Only three outcomes. Okay. And let's look at X represent a monetary reward or monetary loss. And if you look at the first case is loss of 71,000. Second one is a break even with that. So loss of negative 71,000. Okay, and break even, we know that. And then let's take a look at the profit case. That's how much profit you can make. It's 143,000. Okay, so the last one is 143,000. Okay, then let's look at each associate probability. So for the win case is 0.2. You're losing 70,000 with a 20% probability, 65% and 15%. So it's 0.2, 0.65, and 0.15. And again, we're going to look at the average return, right, on the investment under each outcome, x times T of x. And multiply that. The first one will give us a loss of 14,100. No, 200 actually, 14,200. Typo there. Okay, we get that. Second one is zero, right? No break even, $0 reward or loss. And 143,000 times 15% times 0.15. It's turned out to be 21,450. Okay, now according to using the formula, yeah. So average return on all these outcomes is expected value we're looking at. So summation of x times P of x. Okay, now all we just have to do is sum up those numbers: 14,200, adding 0, adding 21,450. And this one, we do have a positive return, which is a good thing, right? Anytime you see a positive return, that means you're making some money out of this investment. So definitely is a good news, $7,250. So yeah, so on average, meaning project B will render a positive return. Will provide an average return of $7,250. And we know that it's positive cash inflow or positive return. So it's a good thing compared to the previous one is negative, a big loss, right? And this one is like not a big gain, but still, you know, you're making a gain. So if you look at, compare these two projects, which one is better off? Has to be project B, right?
Project B.
Exactly. Project B is definitely a better option. So that's good. Okay. That's how we actually tackle the expected value problems. Always, right? Try to figure out what are the outcomes, you know, looking at, and as well as the associated probability. Okay. Sometimes it's a direct, you can find it directly. It's given a question, and sometimes you have to calculate yourself. Like the question, like this one, right? Example number 2. So let's say a local Lions club runs a raffle. Everybody knows raffle, right? It's like lottery, right? So they sell tickets, and there's some prices associated with the tickets. So let's say they tell us 1,000 tickets. Now 1,000 tickets are sold, and that's one first price, which is $25,000. Okay, a Dodge pickup truck, right? So if you win the first prize, you get a 25,000 pickup truck. Now 2 second prizes, okay, each one is worth 15,000. Okay, it's it's a tractor, John Deere tractors, and there are 4 third prizes of $8,000 Honda mowers, right? Mowers, and 5. So all these number actually means something, like 4, 5 fourth price of $650 steel chainsaws. And what is the expected value of a winning if you buy 1 ticket in this lottery? Okay, so you buy 1 ticket, right? So now let's look at all the outcomes. Tell me how many outcomes are there? Anybody figure out that?
It wouldn't be 9.
9 outcomes? Yes, but we considered, so what are those 9 outcomes?
Well, I'm going by where it says there are 4 third prizes of 800, I mean 8,000, and then 5 fourth prizes.
Yeah, I see what you mean. So, so think about this. All like 4 third prizes of $8,000, you treat it like the same reward, right? Same outcome. If you win a third prize, you get the same outcome, right? You get the same Honda mowers, right? That's all you get, $8,000 worth. So if you look at the outcomes here, just look at the, like, you may end up losing, right? $100 because each ticket costs $100, right? That's a loss. You may end up winning the first prize. Does that make sense? You may end up winning the second prize. You may end up with the third prize, and then also 4th prize, right? That's all. So theoretically speaking, we have 5 outcomes. Either you lose $100, you win nothing, right? You lose $100. And we look at all the monetary outcome, monetary reward of a loss here, okay? So if you look at the loss part, a ticket costs $100. You buy 1 ticket, how much can you lose? At the most. it's going to be $100, right? You can only lose $100. That's all. Now, what if you win the first prize, which is 25,000 pickup trucks? What is monetary reward here? How much is it? Is it 25,000 or something else? Okay. One more time, you pay $100, remember, to play the game, to buy the ticket. So here the monetary reward after deducting the cost will be 25,000 minus 100. So this turned out to be $24,900 of the net profit for the first prize. And for the second prize, you can win $15,000 tractors, right? But again, we paying $100. So 15,000 minus 100. So that turned out to be 14,900. Okay. And the third prize is $8,000 Honda mowers. So 8,000 payout minus $100 investment. So that's going to be $7,900. Okay. And then also the fourth prize, that's $650 payout. Chainsaws, right? And then minus $100 investment. So the net gain or net profit is $550. Okay. Now we're going to take a look at the associate probability. It's not given here, but we can figure out that. And we know that that's 1,000 tickets, right? So for 1,000 tickets, for the first prize, that's only one first prize. So probability of winning first prize will be 1/1,000. Okay, one winning ticket over 1,000 tickets. So it's 0.001. Second prize, we have two second prize. That's where this numbers matters. It's in the probability, right? That matters when we talk about the probability. So here we have two winning numbers over 1,000 tickets. So this is 0.002. Okay, so this is second prize. Third prize, $8,000 mowers. We have four of them. So it's 4/1,000. So it's 0.004. Okay. And then the fourth prize, 5 tickets, 5/1,000. That's going to be 0.005. And you probably wonder, what would be the probability of loss? You either win, right? Win one of these, or you lose. You have a loss. Now, what would be the probability of that? How many losing tickets there? Since we have how many winning tickets? 12 winning tickets, meaning the remaining of them are losing tickets. So it's 1,000 minus 12 winning tickets. The rest of them all becomes losing tickets of losing. So this is 988/1,000. So the associate probability is 0.988. Okay. Does that make sense? All right. So look at outcomes. The winning and losing, they are complement of each other. If you know the probability of winning, then you know probability of losing, right? You either win or lose. So now you just multiply across x times p of x. Okay. So multiply -100 times 0.988, and that turned out to be -98.8. The second one, you multiply 24,900 by 0.001. That will give us positive return of 24.9, and 0.002 multiplied by 14,900. And that turned out to be 29.8. And multiply 7,900 by 0.004. So this is 31.6. Positive return, right? All of these are positive return. And you multiply 550 times 0.005, that turned out to be $2.75. Okay, 2.75. Now, if you sum up all this return, that's going to be the expected value, right? So on next page, expected value or average outcome, right? Will be negative 0.98. Adding. Second outcome is 24.9. Adding 29.8. 31.6. And then adding 2.75. Yep. If you combine all of this, that will be the return on the investment. So 98.8 and 24.9 and 29.8 and 31.6 and 2.75, and that turned out to be it's minus, okay. And 0.8 times 2. Okay, so that turned out to be $9 negative 9.75. So the interpretation of this is on average, you expect to lose loss of $9.75 every time you buy the ticket, every time you purchase a ticket. So theoretically speaking, you shouldn't buy too many tickets, right? Because every time you buy the tickets, you lose $9.75 of $100 bet. And for most of the casino, all the casino games, it works in a similar way. You pay to play, but your long-term expected value is usually negative, right? Meaning you have a loss every time you play the game. So it's always not a wise idea to play too much because you end up losing a lot more. Also, I'm going to show you how to do this in Excel really quickly. So let me open Excel. You can get it done in Excel really quickly. Okay. Let me share the screen with you. So once you open Excel, you put in the outcomes, right? We have different outcomes and X, POX, and we also need a product of those two. Okay, now next thing you just have to look at all the outcomes. So we have a loss, first price, second price, third price, fourth price, and that's all our outcomes. And now we're going to give a monetary reward or loss. In this case, again, bullet center for the borders. So the loss, all you can lose is $100, right? And for that, second one is 25,000 minus 100. Okay, we get that. And then the third price, double check the third price. Third price is 24,900. Yeah, so this third price. So second price will be 15,000 minus 100, 8,000 minus 100, 650 minus 100. So this is 15,000 minus 100, get that, and 8,000 minus 100, get that. And last one is 650 minus 100. Okay, so now that. Start with first price is 1/1000. Yeah. Second price 2/1000. Okay. Then it's 4/1000. And last one is 5/1000. Okay, then we have all of this. Then this one actually should be 1 minus the remaining of this, some of those. Sum up all of that. I'll give you 0.98, right? And then from there, let me just put in the dollar sign. Yeah, dollar sign. I guess no decimal. Okay. For this one, no decimal needed. So we'll calculate one of this times that, this, get all of this, and then eventually you just get a total of that, right? That will be the expected value. So sum of this, okay, so it turned out to be $9.75 negative, right? So that's how you handle that in Excel. Okay, any question on this? Okay, now let's continue. Example 3. Maybe this time give you some time to look at it first. Maybe try yourself, see if you can figure out the answer. I give you a couple minutes, think about this. Again, so investment activity. Okay. All right, so let's review the answer for this. How many outcomes are there? Anybody figure out that? Okay, so outcomes, x and p of x times p of x. Okay. So you expect to have two outcomes, right? This one is actually very simple. You either strike the oil or you did not strike the oil. If you strike the oil, then that's a profit. If you did not strike the oil, you have a loss. That's the only thing we have here. Okay. So if you strike the oil, that's $1 million profit, right? So already give you the profit because the initial investment is 250,000 and you win if you receive 1,250,000 and the difference is a profit, $1 million profit. If you lose all your investment, right, which is 250,000. And each one with have associated probability. We know that there's 25% chance of striking oil. In order to make a profit, you have 25% of chance. So that's going to be 25%, which is 0.25. And if you lose, the chances of losing or chances of making a loss will be 75% will be the complement. You either win or lose. So using 1 minus total probability 1 minus 0.25, 0.75. Okay, then next step, you multiply the x by p of x. So 1 million times 0.25, that's 250,000. Okay, and on the loss side, you multiply by 250,000 by 0.75. And this turned out to be 187,000 and $500. Okay. The next thing is to combine those two outcomes, right? The average outcome, combine them. So the expected value on average is the summation of x times p of x. Two outcomes. First one gives us 250,000 return. Second gives us a loss of 187,500. So basically, you find the difference 250,000 minus 187,500, and the difference is the expected value. And that turned out to be 62,500. That means this is a good investment because you do have a positive return. So on average, if you make investments, you expect to have a gain of or profit. You expect to have a profit of $62,500. So definitely, if you have 250,000 to invest, it's not a bad idea, right? Invest in this particular project. Yeah. All right, that's how you tackle the question, analyze it, and get a conclusion about this investment. And let's look at example 4. Okay. Again, I'm going to give you 5 minutes. Look at it, see if you can figure out the answer. Right? And this is like a lot like those lottery games, right? Or Mega Million games. And basically, you put on, you buy a ticket, then you select in this case, select 3-digit numbers between 000 and 999. And if you hit a number, you collect $300. Your net gain is then $298. If you did not hit a number, then you lose $2, right? And you want to see what is the expected value of the gain or loss. Okay, try that yourself. Okay, let's look at the answers for this or solutions. All right, so let's look at all the possible outcomes here, right? Again, you only have two outcomes. Create a table. So let's see what outcomes we expect to have. Either you win some money, right? And lose some money. And so profit, you win, you have a net profit or net gain. Okay. And then you also have a loss, chances of losing that. Okay. And let's take a look at monetary reward, right? If there's a profit and the profit is $298, and if there's a monetary loss, then the profit is $2. And if you look at it, each one has associated probability. And this one is the interesting part, right? How to find out the probability. So first of all, how many winning numbers are there? So you're betting on 007, right? This is the number you're betting on. And for any lottery game or Mega Million, all those gambling or like from lottery companies, all those games, there's always only one winning numbers. Okay. In this case, there should be 1,000 numbers here between 000 and 999. So you're using 999 minus 000, adding 1, right? Including the first number. So that's turned out to be 1,000 numbers. Meaning you're picking one number out of 1,000 numbers, and only one of them is a winning number. So the probability of winning will be 1 over 1,000. This is 0.001. Probability of losing will be the complement. You either win or lose. So it's 1 minus 0.001. So this would be 0.99. Another way of saying this is if only one winning numbers, then the remaining 999 numbers should be losing numbers. So if you're using 999 divided by 1,000, you also get a 0.99. Okay. Now from there, we'll be able to look at the expected return, right? Or expected value, x times p of x. First of all, 298 times 0.001 is 0.298. Okay, then this is a positive return. Yeah. And then you multiply 2 by 0.999. And this is 1.998. Negative 1.998. And then combine them, that's the expected return. So expected return in this case will be negative 1.998, adding 0.298. So this turned out to be negative 1.7, right? 1.70. So the interpretation of this expected return will be every time you play the game, you expect to lose $1.70 every time you play the game. You expect to lose $1.70. Okay. So that's basically how you interpret this outcome, right? Expected value outcome. Okay. Any question about expected values? So anytime when you encounter the problem, always create a table like what I did. Look at all the outcomes. Look at the monetary reward or loss, return or loss, right? And then I'm putting associated probability, then get an average outcome. Combine them, then get an expected value. Okay, that's a general procedure. Now let's take a look at another concept called weighted average. It is a lot of people confused about expected return with the weighted average. So in calculating weighted average, each number in the data set is multiplied by a predetermined weight, right? So it's like associated with each, like your GPA case. So each letter grade is associated with a different like grade point, quality point, right? And we try to make connection between those, and that quality points, it's predetermined based on the grade you earn in each class. And practically speaking, you calculate the weighted average by multiply each value in a set by each weight. And for the GPA case, the weight is the number of credits. So we're going to use GPA as an example to calculate the weighted average. Then you add up the product and divide by the sum of the weights, right? Divide by the product of sum by the sum of the all weights, meaning divide by total quality point earned by the total credits. And that's how you get a GPA, calculate your GPA. So GPA calculation is a typical example of the weighted average. And you probably wonder, every semester, by the end of the semester, all your professors submit a grade, and registrar's office will update your GPA, right? And how do they do that? Okay, we're going to look at it right now. Okay, and this is the formula we are trying to use, right? In the GPA case, W represent number of credit of each course, and X represent the quality points of the grade earned. Right, your grade determines your GPA, right? As well as the number of credits for each course. Now, let's say a student have the following grade in his or her first semester. What was her GPA, right? It's the first semester, so it's just the beginning of the college career. So after you complete the semester, then register office will calculate the GPA for you. And then let's see how register office compute this, right? So this student take 5 courses. So let's say statistics course, right? MA 222, biology course, French course, chemistry course, and history course. And then for the stats course, earn B+, biology course A-, French course B-, chemistry course A, history course C. And each one of them have different credit, 3, 4, 3, 5, 3. Okay. Now, again, remember quality points we're talking about. You can easily look at that. Okay, so I'm going to show you how the quality point was determined at FIT. Okay, so I'm going to go to the Google and then let's find out the quality points, right? Let me share the screen with you. Okay, quality points. GPA, yeah. So you can just type in that and then should have something like this. A lot of school, maybe, let me just type in FIT. Let's see, FIT post this. Yes, it does, right? So here you go. So this is what FIT has posted, as a, so if the grade A, you have an equivalent quality point of 4 points, A- 3.7, B+ has a quality point of 3.3, B has a quality point of 3, B- 2.7, C+ 2.3, all the way to F will give you 0. So basically, we're just gonna use this table as a reference to calculate the GPA for your fellow students, right? This one. Okay. So now one more time. So we're gonna create a table, just like the other one, right? The table will be nice. So the credits is what we call the weight. W is here. And we need to know the X, and after that we calculate W times X. So I'm gonna quickly draw the table. And we know that B+ is 3.3. So the quality points associated with the grade of B plus, 3.3. Quality points associated with A minus grade is 3.7. B minus, I have to quickly look up that. B minus, I think it's 2.7 or 3.0, 2.7. Yes, that's right. B minus 2.7. Okay, go back. And A is definitely a 4.0. Okay. And C, I think it's 2.3, but let's double check. C is 2.0. Okay. Now we get all these grade and associated quality points. Next step, you multiply W by X, right, to get this item. So 3 times 3.3 is 9.9. Okay. And then 4 times 3, 3.7. That's 14.8. And 3 times 2.7 is 8.1. 5 times 4.0 is 20.0. And 3 times 2.0 is 6.0. Okay. And if you look at the formula on the previous slide, in this case, GPA is weighted average. It's a summation of W times X, right? Over summation of W. So we do need a couple things, right? Total credit. We sum up all this credit. It's 7, 10, 15, 18. So total credit is 18. So that means summation of W is 18. Total weight is 18 credit. You also sum up this column by adding 9.9, 14.8, 8.1, 20.0 plus 6. And that's 58.8. This indicates total of the product, W times X, it's 58.8. Now let's apply the formula here to get a GPA. So GPA equal to weighted average. So it's total of the product, 58.8, dividing by 18. And let's see what that is, 58.8 by 18. And that's turned out to be 3.27 approximately. So usually they run into 2 decimal places. Okay, so 3.27, that's a GPA for this first semester freshman. And that's how you calculate GPA using the weighted average. And now, if you have all the grades you earn at the school, and you know the credit for each course, now you'll be able to calculate the GPA yourself, right? Just double check if the register office did the right job for you in terms of calculating the GPA. But that's how you handle this type of question. Okay. Any comment or any concern about this? All right, so this is everything on section 4.2 about the expected value. Now let's look at one more topic today. And next week, we're going to finish the remaining topics and we wrap up the semester. Okay. So next Wednesday, right? Next Wednesday, we will finish all the topics. And next Friday, we will review for the final. So today we're going to finish section 4.3 in terms of multiplication rules. And then next Wednesday, we'll talk about counting Bayes theorem. All right, so now let's take a look at multiplication rules. Okay, open the file. So continue from what we have so far. So on section 4.3, it's about the multiplication rules. Okay, and then the two major things we're going to talk about is a complement event, complementary probability, and also the conditional probability. And this is a very important concept, right? Conditional probability. So it's like given a certain condition, given a condition occurs, and you will have impact on probability. You will have impact on probability. So that's what the definition of the conditional probability is. Probability of event A given that some other event occurs, assuming they are related to each other. Right? And first of all, let's look at the key concept here. First one is at least one. At least one meaning one or more, right? If you want to break down this, it's one or more. And if you want to find a probability among several trials, we get at least one of some specified event. So that if you look at the complement event of at least one is none, right? None of them occurs. Yep.
I can't see your screen.
Okay, yeah, again, sorry, I forget to share that. Okay, yeah, can you see it now?
Yes, thank you.
Okay, very good. So let me go back to the previous slide. So we're talking about multiplication rule in this section. So we're gonna mainly focus on complements and also the conditional probability. As I mentioned, conditional probability is probability of event B given that event A occurs, assuming event A has impact on event B. Okay. So that's the definition of conditional probability, but we're going to go to the details later. But let's focus on key concepts here. First one is called at least one. Right? At least one means one or more. And the counterpart of at least one is none, meaning none of them happens, right? So if you want to find out probability of at least one, you could do total probability minus complement, which is none or no one, right? None. That's typically very useful in a lot of cases, but it's usually very difficult to find at least one event, probability of at least one directly. So we're using this complement event concept to find the probability. And second important thing is called conditional probability. So we try to find out the probability of event when we have additional information that some other event has already occurred. And then this some other event have impact on our designated event, right? On this event. Okay, and then we'll look at that in more detail later on. And again, we're going to focus on some of the important notation. A and B, again, if you draw the Venn diagram, right? A and B meaning both A and B occurs, right? And yeah, so P A and B, event A occurs in the first trial, and event B occurs a second trial. So they both occur at the same time, right? You can also look at it as A intercept B. Okay. That's meaning of this event. And then probability of B given that A occurs. So this sign here is called conditional. Meaning when what happened to probability of B when the event A occurs, right? The probability of event B occurring after event A has already occurred. So event B is conditional based on event A. Okay, so this is a formal notation for the conditional probability. Okay, and so far there's a couple of notations. Now think about this. Probability of A and B occurs at the same time equal to probability of A, assuming A and B are dependent. Meaning, if we know event A occurs, then event A has impact. Event A has an effect on event B. That's why the second you multiply by probability of event B, given that event A occurs. Right, so that's why it's a conditional. And so that's why it's called conditional probability here. So conditional probability. Because event B depends on event A. So any question about this? Right. So when finding the probability that event A occurs in one trial, event B occurs in the next trial, then multiply the probability of event A by the probability of event B, but make sure you take into consideration of event A when we calculate the event probability of event B. Right? Because event A has impact, has an effect on event B. All right, so when we apply the multiplication rule, always consider whether events are independent or dependent. And in the real life, it's very difficult to find out two independent events. So usually two events are dependent in some way, right? It's very difficult to find out two independent events in our daily life or in any like field. They always have some intrinsic, connection. Sometimes not obvious, but still they have connection. Okay. Okay. So now in general, the probability of any sequence of independent events simply is the product of their corresponding probability. So for example, if event A and B are independent, meaning they have no connection with each other, independent. Probability of event A and B, meaning A occurs and event B occurs, will be probability of A times probability of B if they are independent. Right? All right, so two events A and B are independent if the occurrence of one does not affect the probability of the occurrence of the other, right? So they are totally independent, they have no impact on each other. So we call that independent events. If A and B are not independent, meaning they are dependent, so we treat it differently, right? So if it is independent, then A inverse of B should be probability of A and probability of B, right? Because they have no impact on each other. But if they are dependent, A inverse of B becomes probability of A times probability of B, given that A occurs. Now, two events are independent if occurrence of one of them affects the probability of occurrence of the other. It doesn't necessarily mean that they are causal relationship, right? A and B are not causal relationship. May not be causal. Meaning A does not cause B, right? Causal relationship. Or B does not cause A. They just have some connection. That's all. That's causal relationship. So A does not cause B, or B does not cause A. That's what this means. And then also, let's take a look at 5% guideline for cumbersome calculations. If the sample size no more than 5% of the population, then we treat all those selections as being independent. And if you do not pick more than 5% of the sample from the entire population, for example, let's say your entire population is, let's say 10,000 people there, 10,000 people, right? That's the population. If you only pick 500 people, or let's say 400 people in the sample, so pick a sample with only 400 people, right? You survey 400 people, and since it's less than 5%, then we are treating all those 400 people independent. But if, let's say, you're picking 1,000 people, right? You survey 1,000 people, then that 1,000 people becomes dependent. So amount of your sample, also sample size, determines the outcomes, right? If they are independent, it's better off because it's easier that way. You know, if they are dependent, then we have to look into the conditional probability among different events. So that's kind of a different ballgame. Yeah. All right. Now, suppose we have 50 drug test results are given in on people who use drugs, right? So this is so we have positive test result, drug test. So this topic is drug test. And we have negative test results 6, total results 50. If 2 of the 50 subjects are randomly selected without replacement. So what this without replacement indicates, you pick a subject, you examine the outcome, and check the outcome, whether it's positive test result, then put it away, right? It's no longer there. So that particular subject is gone, okay? And now you want to find out probability that the first person tests positive, second person tests negative. So you're looking at this event, right? First positive and second negative. That's how you write this notation. Now, assuming they are independent here because it's quite small sample, right? So if you look at all the drug users, 50 subjects, nothing, right? I'll probably have like maybe 1 million, 2 million drug users, maybe more than that, even more than that, maybe 10 million, 20 million. So 50 subjects definitely is very, very tiny little sample. So we're assuming those 2 subjects, they are independent. And another way of writing this is probability of first positive intercept second negative. So basically what we are looking at is probability because they are independent, right? Independent events. We look at probability of first positive multiplied by probability of second negative. So there are 44 positive test results, right? A total 50 test results. So the probability of first positive intercept second negative. Should be just probability of first positive times probability of second negative. First positive, we have 44 positive test result, 50 of them in total, so 44 over 50. Okay, so that's first outcome. And second outcome, we have 6 negative test results, right? But however, since we pick one and throw it away, then we only have 49 subjects left. So in terms of calculating the second negative test result, we're going to use 6 negative test result over 49. Okay, and this turned out to be the probability. So it's going to be 44 by 50 multiplied by 6 over 49. And this turned out to be approximately 0.1078. So it's 10.78% chance that you pick the first positive, second negative, given condition that without replacement. Okay. And if this case with replacement, that means you pick the subject, the positive test subject, and put it back. So the total result still remain 50, right? If this is the opposite case. But we do not talk about that in this example. This one is just about without replacement. Okay. Any question on this? So you apply the multiplication rule, right? Assuming they are independent. Now think about this. So when two different people are randomly selected from those in your classes, find indicated probability assuming birthdays occur on the same day of the week with equal frequencies. Okay. So for example, probability that 2 persons are born on the same day of the week will be the probability 2 persons with the same birthday. Remember, we have 7 days in a week, so 2 persons could both born on Monday, right? Both born on Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. So you have 1 out of 7 outcomes. Okay, so it's 1 over 7. Okay, on the same day of the week. Both Monday could be both Tuesday. So you have 7 out choices, and you can only have 1 of them, right? 1 over 7. Second one, probability that two people are both born on Monday. Both born on Monday. Then you're going to look at first person, first born on Monday. Assuming they are independent, they are not brothers, sisters, you know, they're not related to each other, right? Second person born on Monday. So there are 2 independent events. If you look at first person born on Monday, 7 days per week, right? Monday is 1 over 7. Second person born on Monday, again, it's 1 out of 7. And you multiply across, you get 1 over 49. So this probability here, they both born on Monday will be 1 over 49. Okay. Do you have any question on this? All right. Now, the tree diagram, actually, we mentioned that already, you know, say it's a picture of all possible outcomes. Remember, let's say like flip coin 2 times, right? We could construct 2 times. we could construct a tree diagram, right? We start here. We know that when we flip it first time, you get either head or tail. This is the first trial. Second trial, we still get a head or tail. So it's head, tail, head, tail. So we have 4 outcomes, right? That's what we call a tree diagram, and this is exactly the demonstration of the tree diagram. So basically, just you can list all the possible outcomes by using the tree diagram. Okay. Now, think about this. Let's say we're going to draw a tree diagram for this question. So summarize the possible outcomes for true/false question, followed by a multiple choice question with 5 answer choices. A, B, C, D, E, right? Let's say 5 answer choices. Usually that's the case, 5 answer choices. So here, we're assuming these 2 questions are independent. So we're going to construct a tree diagram. So we start here. Now for the first question, we only have 2 answer choices, either true or false. Okay. And by the time you get to the second question have 5 answer choices, A, B, C, D, E. So 1, 2, 3, 4, 5. Okay, so A, B, C, D, E. Second one, 1, 2, 3, B, C, D. Now we're just gonna connecting those branches of the tree, right? So TA, you can have a TA. First answer combination, second answer coming TB, TC, TB, T. So that's all start with the true answer, and then with the different answer choices on the second question. You may have FA, FB, FC, FD, FE. So if you look at all these outcomes, there are 10 possible outcomes. So what's the probability getting a perfect score in this quiz? Probability of getting, meaning getting both answers right. Remember, you only have 1 possible combination, correct combination out of 10 possible outcomes. So it's 1 over 10, right? So it's 10% of chance. You can also look at it this way. When you answer the first question, let's say you just randomly pick the answer. You did not study, so you randomly pick the answer. So there's half a chance you getting the first correct answer, right? There's a half a chance of getting, no, that's a 1 over 5 chance you getting second correct answer. So if you multiply across, you also get 1 over 10. So same result. You can look at all the possible answer choices, get the answer, right? Get a correct probability of correct answer. And you can look at each question individually, get a result. They will give you the same answer. And that's how we utilize a tree diagram to list all the possible answers, answer combinations, and calculate the outcome of the probability. Okay. So this is what we call the tree diagram. You can utilize that, all those binary things, right? Like newborn babies, right? Like those, you can also use it to the rolling 2 dice, rolling 3 dice, right? Something like that. And flip a coin, right? All those you can apply the tree diagram to handle that. So let's summarize what we talked about so far, right? So all here from addition rules, A or B indicates addition, right? Addition, usually you draw the Venn diagram, event A, event B. A or B indicates everything A, everything B, also the intercept. So 3 components here. So sum up all of those. And yep, so that's addition rule, right? And then we also talk about the multiplication rule. And the multiplication rule basically, it's this. A and B. I'm only concerned about the intercept part, which is the middle part, right? So that's the meaning of A and B. Okay. And that's a difference between the addition rule and multiplication rules. I guess I should probably draw a small one. A, B, and basically talking about everything A, everything B. And multiplication rule only concerned about intercept, meaning they both occur at the same time, right? So let's look at this diagram or flow chart, help you distinguish when to apply the different multiplication rules. So basically, anytime if you want to use a multiplication rule, you always start with this language A and B, right? They both occur at the same time. And if they are independent, then we have probability of A and B equal probability A times probability of B. If they are not independent, meaning they are dependent, then we're using the conditional probability here, right? Probability of A times probability of B, given that A already occurs, right? So 2 different directions in this case. Now, let's look at this one or more, right? I already mentioned that. And then the complement event of at least one is what we call none. None of them occurs, right? Okay. And complement getting at least one is typically you're getting no items of that type. Okay, now. So now to calculate at least one of something, calculate probability of none, then subtract it from the one, total probability 1. So this is the general guideline we utilize to calculate the probability of at least 1. And if you look at it, think about it, right? Let's say DVD companies offer surprise DVDs in lots of 50 DVDs in a particular package, right? And then you have a reported defective rate of 0.5%, meaning 0.5% of them are defective. That means probability of disk being defective will be 0.005. So you turn 0.5% to a decimal number, it becomes 0.005. So this is what they call a defective rate. And then that follows that probability of disk being good disk will be 0.995. So now you want to think about this. What is the probability of getting at least one defective disk? Meaning one defective disk, 2 defective disks, right? 3 defective disks, all the way to 50 defective disks. And that's a lot of work, right? So that's why you don't go directly here. You probably want to do the complement. So we know that the complement is none. None of them are defective. That means you want all of them to be good CD, right? Or DVD. So probability of at least 1. Here should be 1 total probability minus probability of none. None of them are defective, meaning all good. 50 of them, they're all good. And we know that the probability of being good DVD is 0.995. And we know that we have 50 of them, right? So it's 0.995 times 0.995. You multiply 0.995 50 times to the 50th power. And that is the outcome, right? That is the outcome look at. So here we're assuming those 50 DVDs are independent. Okay, so it's 1 minus 0.995 to the 50th power. And this turned out to be 0.22, approximately 0.2217. That means with a 22%, approximately 22.17% of chance, you'll get at least one defective disk in a lot of 50 DVDs. And if you look at it, it's pretty, the probability is fairly high, right? That means the company could pay more attention to the quality control. If they can reduce the defective rate even lower, then they probably will have a better customer satisfaction when they sell the product. So that's how we utilize the at least one concept, also the complement of at least one to solve this fairly complicated case. Okay. All right, any question on this? Now let's look at the conditional probability. We have to talk about some important elements in this concept. So probability of B given that A occurs, right, represents conditional probability of event B occurring given that event A has already occurred. So it could be finally as a probability of B given A occurs equal to probability of A and B both occurs over probability of A. And this comes from this formula, right? Remember A and B equal probability of A times probability of B given that A occurs. And you just divide both sides of the equation by probability of A, then we get this transform formula, right? So it comes from the multiplication rule, right? Given that they are dependent events. Okay. So this is where this formula comes from. Now, the conditional probability of B given A could be found by assuming event A has occurred and then calculating the probability event B will occur, assuming they are dependent. Okay. So now let's take a look at this table. And this is what we call 2 by 2 contingency table. 2 times 2 contingency table. In this table, we have 2 rows. So you have 2 in a column, we have a positive test result, negative test result. On the row side, we have a subject using drugs and subject not using drugs. So it's 2 categories in each row and then column, right? So that's why it's called 2 by 2 contingency table. And this table, we have some important things here. So each number here represents a different category, right? Like this 44 meaning subject using drugs and then come up with a positive test result. And we also call this correct outcome, right? If subject using drugs, the test result is supposed to be show positive, right? Supposedly. And this one, subject does not use drugs, is 90. However, come up with a positive test result. So this is like error, right? This one is like error. And this is correct. Okay. Now look at this 6 here, subject using drugs and negative test result. Meaning, again, this is an error. They use drugs, but the test result failed to detect that. So that's an error as well. And the last one is 860, not using drugs, negative test result. Again, this is a correct outcome. Okay. And in a lot of tests, right? Drug test, alcohol test, or like any test, right? Pregnancy test, something like that. You're always going to come up with all these 4 different categories. But let's think about this. What if you add in 44 and 90, you get 134? What does that tell us? This 134 indicates positive test result. Total positive test results, right? No matter whether the subject using drugs or not using drugs. Okay. You sum up 6 and 860 here. You get 866. And this number indicates total negative test result. No matter whether subject using drugs or not using drugs. You can also add in 44 and 6, you get 50. And this indicates we have total 50 subjects who use drugs. So 50 subjects using drugs, no matter whether the test result is positive or negative. And then if you're adding 90 and 860, that's 950, and that's total 950 subjects who do not use drugs. Okay, and if you sum up the 50 and 950, you get 1,000. In this case, if you're adding 134 and 866, you also get 1,000, right? Adding these two, you get 1,000. Meaning, in this case, they survey 1,000 subjects, and they come up with these different outcomes, and they separate it into 4 different blocks, right? And each block represents different things. Okay, and this table is very popular and famous, right? In the field, called contingency table. Okay. Now, let's look at this question. What if you want to find a probability that the subject has a negative test result, given that he or she does not use drugs? All right, so the given that, okay. Given that indicates it's a conditional probability. All right, so I accidentally exited. Let me go back. Think about this. So we have a negative test result given that he or she does not use drugs. So probably given a negative test result. Given that not using drugs. This keyword is given that. That's when we know it's conditional probability. And what this is saying is, you're going to look into all the subjects who do not use drugs, which is 90 plus 860, right? Which is 950 people or 950 subjects who do not use drugs. And you want to figure out what percentage of them have negative test results. So if you understand the meaning behind it, you should just going to be 90, right? Negative test result. No, 860 negative test result. Negative test result over total subjects who do not use drugs. Okay, so it's 860 over 950. You can also, and then this is 86 over 95. Okay, so out of all the subjects who do not use drugs, that's what this conditional probability is about. You want to find out the breakdown, right? Like what percentage of them have negative test results? You know, 860 of them have negative test results in that category. So it's 860 over 950. And if you turn into a decimal number, 86 by 95, that's approximately 0.9053. Meaning we have about 90.53% of them who had a negative test result, given that he or she does not use drugs. Okay, so this is what we call the conditional probability. I think that's another question here. Refer to table, find the probability that subject actually used drugs, given that he or she had a positive test result. So this question is use drugs, given that positive test result. All right, so now again, you look into all the positive test results. Total positive test results 134, right? Combine those 44 and 90, you get 134. Out of all 134 positive test results, given condition, then how many of them use drugs? You can find that it's 44 of them, right? So you do 44 by 134. And that's what we call a conditional probability. So this is approximately 0.3284, and that's 32.84%. Okay, and that's how we look at conditional probability. So in essence, it's not that complicated if you find the right category, right? In this case, it's all the positive test results. And then out of all the positive test results, let's see how many of them use drugs, right? 44 of them. So it's 44 over 134. And therefore we get a probability of 0.3284. Okay. And that's pretty much it about a conditional probability. I think I will stop here today. Any questions before we end the session? Okay. Then I'll talk to you guys on Friday then. Bye-bye.
Thank you.
No problem. Bye.
Thank you. Bye.
No problem. Bye.